In this video, I'm going to talk about adding, subtracting, multiplying, and composing two functions. I'm going to do an example of each operation, and then I'll ask you to try your own example to check your understanding as you go throughout the video. The first example I'm going to work through is addition. And if I were to work through this problem, first thing I would notice is that it gives me two functions. One is labeled f of x, the other is labeled g of x. And it's telling me to find f of x plus g of x. So that tells me to add the two functions together. The first step I will do in order to do that is just reorganize it a little bit so I can see which terms I'm working with and try to find like terms. Or going into step 2, which is combining like terms. So it tells me f of x first, so I'll write that one out. And I'm going to put it in parentheses. So f of x is here. It's a quadratic trinomial. So I'll put x squared plus 2x minus 4. And I put it in parentheses just to organize my math and thoughts a little bit better. And then I'm going to add it to g of x. And g of x is listed out right here. It's a linear binomial, and it's 4x minus 2. So that is my first step, just reorganizing it so I can move into my second step a little bit easier. And the second step comes the math. I'm going to start combining like terms. And if you remember from Algebra 1, combining like terms, what makes a term alike is the power that it has or doesn't have. All right? So in this step, I'm going to read it left to right like I would a book. The first term I see reading left to right is x squared. And I'm going to show my math like this, okay? X squared, I can underline it. It does not have a like term in the g of x function. There's no other term in that polynomial that has a power of 2. So I am going to add nothing to this x squared. And I can just show my math with that 0x squared. I'm going to add no more x squareds to it. And I can do that math. Anything plus 0 is itself. That equals x squared. I'm done with that term. Moving to the next leftmost term is 2x. So I can write 2x plus, in this case, 2x does have a like term. In g of x, there is 4x as well. They each have a power of 1. So I can write 2x plus 4x equals 6x. Done with those two terms. And then finally, the constant negative 4 plus the other constant in g of x, negative 2. And that equals negative 6. Cross those out if you want. And my final answer, the new polynomial I get when I combine the two functions together, is x squared plus 6x, because it's positive, minus 6. Remember to write it in standard form with the highest power first, and then so on to the lowest power, and then the constant. So that's how you would do addition. Please pause the video and try your own problem on your own. To check your work with mine, you should have gotten 2x squared minus 6x plus 2. The potential error I would see in this is this step here, working with negatives and positives. Negative 7 plus 5 is a negative 2. And I didn't write that correctly in my answer. You might see that I make mistakes, probably a little bit more frequent than I care to admit. So the correct answer is 2x squared minus 6x minus 2. All right, moving on to subtraction. It's the same functions we're going to be working with. So the first step for all of these will be the same. So I will write out f of x. So again, we're referencing the original two functions. We'll be working with those throughout the video. So x squared plus 2x minus 4. And now minus instead of plus 4x minus 2. So the terms will interact with each other a little bit differently. If you notice, we used to be adding, now we're going to be subtracting. It's still technically combining like terms, but the process of combining is different. You're going to subtract them from each other. If you notice, there's no x squared term in g of x, so I just subtract 0 from it. And that'll still give me x squared. That one's done. And then I go to 2x. Its like term is 4x. 2x minus 4x in this case is negative 2x. And then finally, negative 4 minus a negative 2. And again, this is where errors exist because you're working with positives and negatives and subtracting a negative from another negative. Anyways, the correct math in that turns to addition. Negative 4 plus 2 is a negative 2. So the final answer in this case is x squared minus 2x minus 2. All right. Go ahead and pause your video and try your example on your own. All right, if done correctly, you should have gotten 2x squared minus 2. Keep in mind the linear terms, negative 3x for both functions, they cancel out because it's a negative 3x minus a negative 3x here. That turns to positive. Negative 3 plus 3 is 0. And in your final answer, you never have to write a term that has a coefficient of 0. Moving on to multiplication, 2 more. So multiplication becomes a little bit more in-depth, but still pretty straightforward. First step remains the same. I'm going to write out the functions. X squared plus 2x minus 4 is f of x. And I'm going to multiply it, so I can just write 2 parentheses next to each other by g of x, which is 4x minus 2. Now, when multiplying polynomials together, a key word called distribution comes into play. Distribution means that every term from f of x has to multiply with every term from g of x. And there's a couple different ways you can organize your work. I'm going to show you a way that I use. And for this particular strategy, I'm going to use an area box. And I'm going to draw it as a simple rectangle. I'm going to put f of x on top, so x squared plus 2x minus 4. And then g of x along the side, the left-hand side, I'm going to write 4x minus 2, like that. Now I need to organize my area square a little bit. Don't know if that's the technical term, but I'm going to separate the x squared column, the 2x column, and then the negative 4 has its own column. And then I'm going to create a row between 4x and negative 2. This, again, is just an organization tool. Now it tells me that every term is going to be multiplied with each other one time. And I go ahead and do that, so it's going to be 4x times x squared, which becomes 4x to the third. Remember, you add powers when you multiply. Add powers to the variables. 4x times 2x becomes 8x squared, and 4x times negative 4 becomes negative 16x. Moving to the second row, negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times negative 4, negative times a negative becomes a positive 8. One last step, because within distribution of polynomials, a lot of times the second step will be combining like terms. And so in this case, I'm going to look for like terms. 4x cubed does not have a like term. There's no other cubes within my rectangle. But 8x squared is a like term with negative 2x squared. So I can do some side math. 8x squared plus negative 2x squared, because we're combining like terms, and that equals 6x squared. And then finally, negative 16x is a like term with negative 4x. So negative 16x plus negative 4x becomes negative 20x. And then my final step, so this was step 1. Step 2, my final step is just to write the new polynomial in standard form, highest power to lowest power into the constant. So the highest power is 4x cubed. The squared term becomes positive 6x squared, so plus 6x squared, then minus 20x, and then the constant of positive 8 plus 8. And I am done. All right, go ahead and pause the video and try this one on your own as well, multiplication. Example C correctly, multiplying two polynomials, you should have gotten negative 6x cubed plus 19x squared plus 6x minus 35. Keep in mind combining like terms here. All right, last example of the video. Thank you so much for watching so far. In this, if I was presented with this operation, it's called composition, meaning you compose one function into the other function. If I was to say this out loud, this would become g of f of x. And a lot of times I ask the question to myself, the function f of x has gone in place of or inside of the function g of x. So if I go back to my example up here, the function f of x right here, this whole entire function goes into g of x, and the only place it can go into is the variable of g of x, which is the x with the 4, all right? Meaning variable stands for that, it can change, and so that variable is going to change into the function f of x. And I know that f of x is going into g of x because it's inside of the parentheses of g of x. So I'm going to write 4, let me just show you, g of x equals 4x minus 2, yes, sorry. 4x minus 2, okay? I'm going to put f of x into that variable, so I'm going to write g of f of x to be 4. Instead of x, I'm going to write a big parenthesis, because it needs to include the 3 terms of f of x. And then I'm going to put minus 2 on the outside, because that still exists there. Now, f of x is x squared plus 2x minus 4. So again, f of x right here went into g of x, the variable of g of x. That's how I would set it up. And then the first math that comes into play is distribution. This 4 is going to distribute into all of those terms, and then we're going to combine like terms with that negative 2. So 4 times x squared is 4x squared. I could show my math, I suppose, keep in mind with what we've been doing. So 4 times x squared is 4x squared. 4 times 2x equals 8x. 4 times negative 4 equals negative 16. So now I have 4x squared plus 8x minus 16 minus 2. Remember, we can't forget that 2. I have to drop it down. And then these two terms combine, so I get 4x squared plus 8x, and then negative 16 minus 2 is a negative 18. And I am done. Alright, pause the video one last time and try yours. Compose the two functions correctly, you should have gotten negative 6x squared plus 9x plus 26. Please raise your hand if you have any questions or would like further explanation.